Welcome to this course on Linux privilege escalation. Thank you very much for purchasing the course. I hope it provides some useful insights into privilege escalation on Linux systems, which is especially useful if you are planning on taking the OSCP exam. Some quick information about myself to start things off. I've been a penetration tester for about 7 years, but I've been using Linux and Unix-like systems for about 13 years. I am OSCP certified, and I use a lot of what I'm about to teach on the course, both in the OSCP labs and in the exam. I'm the creator of the Auto Recon tool for enumeration, again something I used in the labs and the exam. It's not PrivEsc related, but if you are stuck trying to enumerate services on lab hosts, I would definitely recommend giving it a try. Finally, I'm one of the admins of the InfoSec Prep Discord server, which is aimed at trying to support students of InfoSec. We have many OSCP certified members who are willing to help out with any questions you have, but if you want to message me directly about anything to do with the course, you can find me there. As a little overview, this course will focus on privilege escalation techniques in Linux and Unix-like systems, not Windows. After completing this course, you should know how basic user privileges work in Linux, as well as multiple techniques for escalating your users' privileges. More importantly, you should learn why and how these methods work. Finally, we will learn how to use some tools to help identify privilege escalations. As far as I'm aware, all the tools I'm going to show you are perfectly fine to use in the OSCP exam too, and I definitely recommend using tools in the exam to save time. So what will you need before starting this course? Well, I'm not going to teach how to use Linux. I will certainly be showing you all the commands necessary to find and exploit privilege escalations, and in some cases I will explain the command in detail. But if you are new to Linux, you should definitely read up on the basics and be relatively confident with the Linux shell. This course also won't cover how to exploit a system to get a low privilege shell. This is a post-exploitation course, so everything is going to assume that you already have a full working shell as some user on the system. We will be using a vulnerable Debian VM for the course, which was created as part of a local privilege escalation workshop, not affiliated with the course. The VM is special in that it contains multiple misconfigurations which allow privilege escalation. You can download the VM from the Udemy course page. This is recommended as this version has a few new methods of privilege escalation which I configured. The low privileged user account password is password321. The root user account, which you can use if you need to configure the VM or reset something, is password123. However, if you've already got the Debian VM set up because you tried out the workshop before, you can download a bash script I wrote from the URL on the screen, and as long as you run it as the root user, it should perform all the extra misconfigurations. A quick disclaimer for this course. This course was designed with the OSCP labs and exam in mind. However, it attempts to cover a wide range of escalation techniques beyond what an OSCP student is expected to understand. Understanding that privilege escalation is often highly complex and new techniques are developed over time, this course is not intended to be a complete guide to every privilege escalation technique. When appropriate, the author will update the course materials to include new techniques which are considered to be valuable. Finally, some acknowledgements. Without the people or organizations on the screen, this course would have been significantly harder to develop, and my gratitude goes out to them. Privilege escalation in Linux. Our ultimate goal with privilege escalation in Linux is to gain a shell running as the root user. Privilege escalation can be simple, e.g. a kernel exploit, or require a lot of reconnaissance on the compromised system. In a lot of cases, privilege escalation may not simply rely on a single misconfiguration, but may require you to think and combine multiple misconfigurations. All privilege escalations are effectively examples of access control violations. Access control and user permissions are intrinsically linked. When focusing on privilege escalations in Linux, understanding how Linux handles permissions is very important. Understanding permissions in Linux. At a basic level, permissions in Linux are a relationship between users, groups, and files and directories. Users can belong to multiple groups, and groups can have multiple users in them. Every file and directory defines its permissions in terms of a user, a group, and others, which means all other users. User accounts are configured in the /etc/password file. User password hashes are stored in the /etc/shadow file. Users are identified by an integer user ID, also known as a UID. The root user account is a special type of account in Linux. It has a UID of 0, and the system grants this user, or more accurately grants this UID, access to every file. Groups are configured in the /etc/group file. Users have a primary group and can have multiple secondary or supplementary groups. By default, a user's primary group has the same name as their user account. All files and directories have a single owner and a group. Permissions are defined in terms of read, write, and execute operations. There are 3 sets of permissions, one for the owner, one for the group, and one for all other users, which can also be referred to as world. Only the owner can change permissions of the file or directory. File permissions are self-explanatory. When the read permission is set, the file contents can be read. When the write permission is set, the file contents can be modified. When the execute permission is set, the file can be executed, i.e. it can be run as some kind of process. Directory permissions are slightly more complicated. When the execute permission is set, the directory can be entered. Without this permission, neither the read nor the write permissions will work. When the read permission is set, the directory contents can be listed. When the write permission is set, files and subdirectories can be created in the directory. There are 2 special permissions which we will cover in this course. The first is the setUID or SUID bit. When this is set, files will get executed with the privileges of the file owner. The second is the setGID or SGID bit. When this is set on a file, the file will get executed with the privileges of the file group. When this is set on a directory, files created within that directory will inherit the group of the directory itself. The ls command can be used to view permissions. The first 10 characters indicate the permissions set on the file or directory. The first character simply indicates the type, e.g. a dash for a file or a D for a directory. In the example above, the first character is a dash, meaning that /bin/date is a file. The remaining 9 characters represent the 3 sets of permissions: owner, group, and others. Each set contains 3 characters indicating the read, R, write, W, and execute, X, permissions. SUID and SGID permissions are represented by an S in the execute position. So if we go back to the output of this command, the file is owned by root and is in the root group. The root user can read, write, and execute the file. Members of the root group can read and execute the file, but they cannot write to it. And finally, everyone else on the system can read and execute the file, but cannot write to it. I previously stated that users are identified by a user ID. In fact, each user has 3 user IDs in Linux: real, effective, and saved. A user's real ID is who they actually are, the ID defined in /etc/password. Ironically, the real ID is actually used less often to check a user's identity. A user's effective ID is normally equal to their real ID. However, when executing a process as another user, the effective ID is set to that user's real ID. The effective ID is used in most access control decisions to verify a user, and commands such as whoami use the effective ID. Finally, the saved ID is used to ensure that SUID processes can temporarily switch a user's effective ID back to their real ID and back again, without losing track of the original effective ID. There are a few commands we can use to print user IDs. Here we see the ID command, which prints real IDs of the user and the effective IDs if they are different. In this case, the user's real ID is 1000, and their real GID is also 1000. However, their effective ID is 0, and their effective GID is also 0. The second example will print the real, effective, saved, and file system IDs of the current process, which in this case is our shell. We will not cover the file system ID in this course, but it is usually the same as the effective ID. As with the ID command, we can see that our users' real IDs are both 1000, and their effective and saved IDs are both 0. Spawning root shells. As stated in the introduction to this course, our ultimate goal is to spawn a root shell. While the end result is the same, executing /bin/sh or /bin/bash, there are multiple ways of achieving this execution. In this course, we will use a variety of methods. This section highlights a few which can be used in situations where commands can be executed as root. The root bash SUID. One of my favorite ways to spawn a root shell is to create a copy of the /bin/bash executable file. I usually rename it root bash. Make sure it's owned by the root user and has the SUID bit set. A root shell can then be spawned by simply executing the root bash file with the -p command line option. The benefit of this method is it is persistent. Once you run the exploit, root bash can be used multiple times. Custom executables. There are many instances where some root process executes another process which you can control. In these cases, the following C code, once compiled, will spawn a bash shell running as root. You can compile this code using the command shown. MSF Venom. Alternatively, if a reverse shell is preferred, MSF Venom can be used to generate an executable .elf file. This reverse shell can be caught using Netcat or Metasploit's own multi/handler module. Native reverse shells. There are multiple ways to spawn reverse shells natively on many Linux distributions. A good tool for suggesting this is the RSG tool, or Reverse Shell Generator. All of these can be caught using a simple Netcat listener. Privilege escalation tools. You may be asking, why do we even use tools? Well, tools allow us to automate the reconnaissance that can identify potential privilege escalations. While it is always important to understand what tools are actually doing, they are invaluable in a time-limited setting, such as an exam. In this course, we will use Linux Smart Enumeration and linenum. Linux Smart Enumeration, also known as lse.sh, has recently become my personal favorite privilege escalation tool. In addition to being a bash script, which helps if Python isn't installed, it has multiple levels which gradually reveal more and more information. You can download Linux Smart Enumeration from the link shown. Here I am logged onto the vulnerable Debian VM using the low-privileged user account. If I list the files in my home directory, we can see that I have transferred the Linux Smart Enumeration script across from my local machine. I just need to make sure that the script is executable, which I can do with the chmod command. Let's run the script with the -h command line option to see what we can do. There's several options here, but the script doesn't require much configuration. Let's run it with the default options and see what happens. The first thing it does is ask if I know the current user's password. Let's assume that I don't, which is likely if I got my shell using some exploit. I can disable this question by giving the script the -I command line option, but for now I'm just going to press enter. The script finishes relatively quickly. By default, it will only show the most interesting results. These are things that have a high likelihood of privilege escalation. Now let's rerun the script with the -L command line option set to 1. I'll add the -I command line option too, so it doesn't prompt for a password. As you can see, there's much more information printed now. Not all of this might be important to getting root, but if none of our options from the first run were fruitful, we should look through the new information here and see what we can do. Finally, let's rerun the script with the -L command line option set to 2. This will print out everything the script gathers. There's a lot of information here, and most of it is probably not going to get you anywhere, but perhaps you will spot something you didn't before in these results. We'll come back to the Linux Smart Enumeration results multiple times in the course, as we learn about different types of privilege escalation. linenum is also an advanced bash script which extracts a large amount of useful information from the target system. It can also copy interesting files for export and search for files containing a keyword, e.g. password. You can download linenum from the URL shown. On the Debian VM, I'm again logged in as the low-privileged user account. I've downloaded the linenum script, and I'll make it executable. Let's run the script with the -H command line option to see what we can do. A great feature of this script is the ability to copy potentially interesting files for export. Let's create a directory where the script can copy files to. Another good feature is the ability to search for a certain keyword. Let's try searching for the keyword password. We'll give the script the export directory, and for good measure, we'll include thorough tests. The script outputs a lot of information, and you should read through as much as possible. The export directory now contains copies of several interesting files on the system. You can zip up the directory and transfer it to your local machine for further analysis. There are a few other tools that are useful for Linux privilege escalation, and while we won't use these tools in this course, feel free to experiment with them. The 3 I've displayed on the screen are ones that I have encountered in the past and have found to be quite helpful.